Okay, so remember this is part B, so we want to use part A. So the first thing kind of doing after I've read the question is just having a look at things like, how they're similar. So you can see from A, we've got 1 plus I tan theta here. And here in the question, we've got 1 plus z to the power of n to the power of 4. So hopefully you can see that straight away and you think, oh, okay. So we want to show also, that z is, just to note, purely an imaginary number. Well, that's handy too, because what we can do from that just comparison is say, well, let's let z equal our I tan theta. So yes, it is purely imaginary if we do that. And we also want n to be 4. Okay, so it just said to show that if z is a purely imaginary number, okay, we've made it an imaginary number. The roots of this are that. Okay, so the roots of this are that. All right, well, let's put in our let z equal I tan theta and n equals 4 into that equation. And what do we have? So we've got 1 plus I tan theta to the power of 4 plus 1 minus I tan theta to the power of 4. And that equals 0. But from A, remember, we know that, looking again at A, that is the same as, if we put n equals 4 in there, that left-hand side is the exact same as 4 theta, 2 cos 4 theta on cos to the power of 4. Okay, so that is exactly the same. And that's much easier to solve if you're finding the roots. So to find those roots, remember, if you look at the top has to be 0. So 0 divided by anything is 0. So we're really just solving 2 cos 4 theta equals 0. Divide by 2, we're really just solving cos 4 theta equals 0. Now, just as a bit of an aid, because it's 0, you can just look at I like to just go back and look at my cos curve. In my cos curve, I can see where my zeros occur, just kind of easy, the ones nearest 0. So that means my 4 theta is going to be plus or minus pi on 2 and plus or minus 3 pi on 2. And of course, if we divide by 4, we get plus or minus pi on 8 and plus or minus 3 pi on 8. Okay, let's just go back here to the question now. It says, let me get my other pen. So we're showing that the roots are these two, z equals plus minus I tan. Okay, so what have we got here? We've got the theta, but we have to put it back into our z here. We said let z equal I tan theta, and z, of course, are the roots. Yeah? So if we just put those thetas into z, so therefore I'll just put it up here so I can't fit. So therefore, what have we got? We've got our z equals I tan plus minus pi on 8 and I tan plus minus 3 pi on 8. But that's not the answer, because look at that, plus minus is in front. Why can we just put it in front? Think about that for a second. What do you think? What do you know about the tan function? Okay, the tan function, remember, is an odd function. Yeah, so if I put in a value here, put in a value here, it's an odd function. So if it's an odd function, remember that. So tan of negative theta is negative tan theta. So that's why that works. Hope that helps.